This video gives more example of discriminant questions where you're trying to find an unknown parameter like k or m. I will go through 4 different examples. Feel free to pause as I go through this. Okay, the straight line L crosses the y-axis as 0, minus 1. So I know because it crosses the y-axis as 0, minus 1, linear equation take the form y equals mx plus c. So this equation must be of the form y equals mx take away 1. Okay, so I'll write that down as my equation of my line. The curve with equation y equals x squared plus 2x has no intersections with L. So no intersections, so this line and this curve do not intersect. So when we combine these two functions, we're expecting the discriminant to be less than 0 because they have no intersections. Determine the range of the possible values of the gradient of L. Okay, so we've got y is equal to mx take away 1. Here's the equation of our line. We've got y is equal to x squared plus 2x. Because they both have y as a subject of the formula, we can equate the two. So we get mx take away 1 must be equal to x squared plus 2x. Let's move everything to the right hand side. So we end up getting x squared plus 2x take away mx plus 1 is equal to 0. So this is a combined function. Let's factorize the x out for the middle two terms. So I get x squared plus 2 take away m, lots of x, plus 1 is equal to 0. So this is a combined function. Okay, now in this case, a is equal to 1, coefficient in front of x squared, b is equal to 2 take away m, and c, so I'll drop the 1 there, c is equal to 1. Okay, which means discriminant is equal to b squared take away 4ac, which gives me 2 minus m squared take away 4 times 1 times 1. If I expand the 2 minus m squared, I get 4 take away 2m take away 2m plus m squared take away 4, which gives me m squared take away 4m. Now I know the discriminant is less than 0 because there are no intersections, which implies m squared minus 4m must be less than 0. If I factorize it, I get m times m minus 4 is less than 0. This is a quadratic inequality, so always do your sketch. Your two roots are 0 and 4. This is a positive quadratic, so it looks like so. Okay, we're looking for the part that is less than 0, so below the x-axis, and the range of values that give you these, so everything between 0 and 4. Again, it's a strict inequality here, so my solutions will have strict inequality, so it means everything, all m values between 0 and 4, and that would be my solution, final solution for that one. Show that the quadratic equation k plus 1 times x squared plus 2kx plus k is equal to 1 has two distinct real roots for all values of k except for one value which must be stated. Okay, so the first thing I need to do is, I know that because it's got two distinct real roots, that means the discriminant must be greater than 0. Okay, so now my quadratic equation, I need to make it equal to 0. So if I do that, I've got k plus 1 x squared plus 2kx plus k take away 1 is equal to 0. Okay, so that means in this case, my coefficient of x squared is a, which is k plus 1, k plus 1, b is equal to 2k, and c is all the constant at the end, which is k minus 1. Okay, my discriminant is b squared minus 4ac, which is 2k all squared, take away 4 times k plus 1 times k minus 1, which gives me 4k squared, take away 4 times k squared, take away 1, which gives me 4k squared, take away 4k squared plus 4. Okay, which gives me 4. Now remember, the discriminant is greater than 0. Discriminant is greater than 0. But 4 is always, discriminant is 4, which is always greater than 0. So this must mean it's true for all values of k. For all, I should say, real values of k. But obviously this is not true for one value, because we're trying to find that one value where it doesn't work. Now this is a quadratic. Now if it's a quadratic, then we need k plus 1. So if it's a quadratic, we want the x squared term to be present. So when is the x squared term not present? We know that when k is equal to negative 1, let's rewrite that. When k is equal to negative 1, when k plus 1 x squared plus 2kx plus k minus 1 becomes just minus 1 plus 1 times x squared plus 2 times minus 1x plus minus 1, take away 1. Notice how this x squared disappears, which becomes minus 2x minus 2, which is not a quadratic. So our quadratic has reduced to a linear function. So that means it's true for all values of k except for k is equal to negative 1, because our quadratic reduces to a linear, which means you can't solve it. So therefore, it has two distinct real roots for all real k except k is equal to negative 1. Because when k is equal to negative 1, this quadratic reduces to a linear, so we can't have that case. The straight line has equation y is equal to kx minus 9, where k is a constant. The curve C has equation y is equal to 3 times x plus 1 squared. It is further given that L is a tangent to C at the point P. Determine the possible coordinates of P. The first thing I know is tangent implies meets at one point. If it meets at one point, they have one solution, which means the discriminant must be equal to 0. Okay, I've got the two equations, y is equal to kx minus 9 and y is equal to 3 times x plus 1 squared. Because they both have y as the subject of the formula, I can combine them by equating them. So I end up getting kx minus 9 must be equal to 3 times x plus 1 squared. If I expand the right hand side, I get kx minus 9 is equal to 3 times x squared plus 2x plus 1. Kx minus 9 is equal to 3x squared plus 6x plus 3. If I take everything to the right hand side, I end up getting 3x squared plus 6x plus 3. Take away kx plus 9 is equal to 0. Okay, if I rewrite this in with 3x squared plus 6x, take away kx plus 12 equals 0. I need to factorize the x out here, so I end up getting 3x squared plus 6 take away k times x plus 12 is equal to 0, and this is my combined function. Yeah. Okay, so in this case, I'm just going to go here. My A is equal to 3. My B is equal to 6, take away K. And C is equal to 12. So my discriminant is B squared take away 4AC is 6 take away K squared minus 4 times 3 times 12. If I expand that, I get 36 take away 6K take away 6K plus K squared. 4 times 3 times 12 gives me negative 144. Take away 144. And if I simplify this, I get K squared take away 12K minus 108. That is equal to 0. So that means K squared take away 12K take away 108 is equal to 0. If I factorize this, I want two numbers that multiply to give you negative 108, add to give me negative 12. So positive 6 times negative 18 gives me negative 108. 6K take away 18K gives me minus 12K. So I have 6, K is equal to negative 6 or K is equal to 18. Okay, now when K is equal to negative 6, okay, my combined function becomes 3x squared plus 6 take away minus 6x plus 12 equals 0, which becomes 3x squared plus 12x plus 12 equals 0. If I divide by 3, I end up getting x squared plus 4x plus 4 equals 0, which factorizes to x plus 2 times x plus 2 equals 0, which implies x is equal to negative 2. So you only get one solution, which is true because it's a tangent. So you are expecting one solution here. Now x is equal to negative 2. Now if x is equal to negative 2, because y is equal to kx minus 9, y will be equal to negative 6, so k is negative 6, times negative 2 take away 9, which is 12 take away 9, which is 3. So your point P is equal to negative 2, 3. Now that's the solution when k is equal to negative 6. Obviously there is another solution when k is equal to 18. So when k is equal to 18, your combined function reduces to 3x squared plus 6 take away 18x plus 12 is equal to 0, which becomes 3x squared. 6 take away 18 gives you minus 12. Minus 12x plus 12 is equal to 0. If I divide by 3, I get x squared take away 4x plus 4 is equal to 0. If I factorize this, again I'm getting x take away 2 times x take away 2, which means my solution is x is equal to 2, which makes sense. Again, we're getting one solution is a tangent. So x is equal to 2, your y is equal to kx minus 9 again. Your k in this case is 18, your x in this case is 2, take away 9, which is 36, take away 9, which is 27. So your point will be, second solution for your p value is 227. And that would be your final answer. Last example I will go through. The figure above shows a graph of the curve C with the equation y is equal to root of 2x minus 4, with x greater than or equal to 2. The point P lies on C so that the tangent to C at P passes through the origin. So if it's a tangent, it implies it meets at one point, which means the discriminant must be equal to 0. Now this tangent, because it goes to the origin, I can write it as y equals mx plus 0, which is just y equals mx. So my two equations are, so what we're trying to find out, the point P lies on C, so the tangent to C passes through the origin O, determine the coordinates of P. Okay, so that means I've got my equation y is equal to mx and y is equal to root of 2x minus 4. If I combine the two, because y is a subject, I can combine the two by equating them. Mx must be equal to root of 2x minus 4. Now, I don't like the square root sign, so I'm going to square both sides. So I get mx all squared must be equal to, when I square the square root sign, I just get rid of it. So I get 2x minus 4, which gives me m squared x squared is equal to 2x minus 4. If I take everything to the left-hand side, I get m squared x squared, take away 2x plus 4 is equal to 0. This is my combined function. Okay. My a is equal to m squared here, my b is equal to negative 2, and my c is equal to 4. Which means my discriminant is equal to b squared minus 4ac, which is negative 2 squared, minus 4 times m squared times 4, which gives me 4 take away 16m squared. Now I know the discriminant is equal to 0, which implies 4 minus 16m squared is equal to 0, which factorizes to 2 minus 4m times 2 plus 4m is equal to 0. Which means either m is equal to 2 over 4, which is a half, or m is equal to negative 2 over 4, which is equal to negative a half. Now if I look at my line there, m is positive because it's a positive gradient, so it can't be m is equal to negative half, it must be m is equal to a positive half. Okay, so if m is equal to a half, it implies my combined function becomes half squared x squared, take away 2x plus 4 is equal to 0. Half squared is a quarter, so a quarter x squared, take away 2x plus 4 is equal to 0. Okay, I need to times by 4 to get rid of the quarter. So if I times everything by 4, every term by 4, I get x squared, take away 8x plus 16 is equal to 0. This factorizes to give me x take away 4 times x take away 4, which gives me one repeated root, which makes sense because we're looking at a tangent. So x is equal to 4. If x is equal to 4, y is equal to root of 2 times 4 take away 4, which is equal to 8 take away 4 square rooted, which is root 4, which is just 2. Which means my point P must be equal to 4, 2. That would be my solution.